Okay, so welcome again, and my name is Roberto Turrin, and with me there is Andrea Cappelli.
Hi everybody again.
Who's a data scientist in Cloud Academy with a special expertise in natural language processing. Today we are going to talk about Google Natural Language, and in particular we are going to make you aware of the capabilities of these APIs and how to set up. Therefore, we will try to use the service in order interesting questions, and it's a kind of example of using this interface. And we will make a sort of demo using a Jupyter notebook where we will use Python as language. So I hope most of you are familiar with Python, otherwise it will be very straightforward to be followed. And finally, we will draw some conclusions and we will try to answer to your questions. So, what you will learn during this webinar? Our goal is to make you understanding what Google Natural Language is and how the API works. Especially, we will see that given as input text, the output is a JSON file where you have several features such as entities, syntax, and semantic. And all these features can be used for you to create something interesting, to analyze your text, to understand something more about your text. I will show you something with an example. In order to understand this output, you need to understand the syntax parts of this output and especially the part of speech of the output. And I will make you some example in order to make it clear later. If you want to try what we are going to show you to you right now, you will need a Google Cloud Platform account and I will say a basic knowledge of natural language processing. And since most of our example will be in English, of course, understanding basic English syntax and grammar. So let's start with an example. I will go to the Google Natural Language webpage, and I will try to make you understanding how it works. There is a very simple example that we can run, and here you can, of course, you can have your own account, but you can also use this demo in order to understand the capabilities of the service. Let's try with this simple sentence. Homer Simpson stole Ned's air conditioner. And just clicking on Analyze, in a very few milliseconds you get an answer by Google Natural Language API. And you see that right here there are 3 tabs. One is about entities, one is about sentiment, and the last one is about syntax. Entities are quite straightforward to understand. They are the objects that have been recognized by the service. And for example, in our case, there is Homer Simpson, which is understood by the service. And much more interesting, the fact that there is a link to a Wikipedia page, which can have different features to be used. Again, the service recognizes Ned, and again, there is a Wikipedia article linked to this entity. And finally, there is air conditioner, which has been recognized as a single entity. So you can understand that the service recognizes that air and conditioner are the same, a single object, basically. The number you see just below each entity, the silence value, represents the importance of this entity for the sentence. That means that Homer Simpson is much more important than air conditioner and Ned in representing this sentence. This is something that can be useful in some cases when you want to identify the most important entities, and for example, you want to just to make you a very simple example, create a summary of a text. You can extract the most important entities and creating the new summarized sentence starting from these ones. Let me go to the sentiment tab. Here you can see how the service understood the polarity of this sentence. And this is a slightly positive sentence. Both score and magnitude are reported. As far as we understood, the score is a number between -1 and +1, while the magnitude is the sum of the scores. There is not really a clear documentation about it. Our understanding is this one. You can, when you have some, let's say, bad sentence that talks about some negative ones, you will find a negative score, and so you can understand that. Just to make you an example, someone is talking badly about you just because the sentiment recognizer identified a negative score about this document. And finally, there is the syntax tab, which is, in my opinion, the most important and also the most rich one. Let me start with by removing some comments and just leaving up the part of speech. Part of speech just recognizes whether it is a noun, a verb, a punctuation, for example. And starting from this, in the case it is a verb, you can have the normal form. For example, stole has been understood as steal. And you can finally add a label which reports to you the role of each token within the sentence. So, for example, you understand that the root of the sentence is this verb, steal, and linked to this one there are the other parts of the sentence. Just to understand which the other parts are, you can add the dependency and the morphology, so you can have the full output of this API. So starting from the root, we can have a link to Simpson, which is link again to Homer. So you understand that the root is the verb steal, so stealing, and the subject of this is Homer Simpson, because Simpson and Homer are linked together. And finally, we can have the object of this sentence, which is conditioner, which is linked to air. So in the end, the final object is air conditioner. And what else? You know, we can understand who's the owner of air conditioner, because we have this possessive term, and this is again linked to air conditioner, so we know which is the owner of this object. And these are all information that can be retrieved from this API. Of course, this is a demo, but we can have exactly the same information as using an API that can be called by using either a client or any REST call, and you get as output a JSON that represents the same information. Just to add you some data, for each term, we also have whether it is singular or plural in the case of a noun, the tense of the verb, the mood of the verb, etc. We realized just recently that not everything always works fine. And for example, if here we use the plural form of air conditioner, and we watch at syntax, well, air conditioner is recognized as singular. And that's something that has not been correctly recognized, regardless the fact that the lemma is converted to conditioner in its plural form. Okay, so now that we understood how this API and what's the main output of this API, I will let Andrea describe as an example of using this API to create something cool.
Okay, thank you, Roberto. So the example that we wanted to show you about how to use these API, particularly the entity retrieval and the syntax analysis ones, is to try to build questions about some text. So we start from simple sentences from a text that you can find online or somewhere else, and we try to build something that requires a response or an answer from the user. So let's start with the sentence that we just used for these examples. Using the entity retrieval endpoint, we can get, as we have shown you, the two main entities of the sentence, which are Homer Simpson and Ned, clearly Ned Flanders. And you can use this information to remove one of them, and for example, just create a fill in the blank exercise that a user can, or a user or somebody who wants to play with this sentence can use to just try and guess what was the original name that was in the sentence. Another maybe less colorful but more maybe more interesting way is to use the syntax tree of the sentence, the one we have just shown, in a similar way. So thanks to the syntax analysis, you get the information of which tokens depend on which inside the sentence. It may sound something maybe too detailed, but actually it allows to group tokens together, so that if you remove one of some or some of them, you do not leave parts of the sentence which do not make sense anymore due to the removal. In other words, if we want to remove the direct object of the sentence, which is conditioner, we also want to remove nets and air, because otherwise those parts of the sentence would not make sense anymore. And in this way, we can use those pieces of the sentence that we have just torn apart to create two new sentences. One, which is a question, what did Homer Simpson steal? And the other one, which is affirmative and corresponds to the part that we have just removed, which is Ned's air conditioner, which is also the correct answer to the question that we have just created. How did we decide that we had to create the expression, what did Homer Simpson steal? We had stole in the beginning, in the original sentence. The point is that we have the information about the lemma corresponding to the form stole. Stole is one way that the verb steal can appear, and the API told us that. We have this information from the syntax API, so that we can just create a very simple algorithm that can transform stole into what did something something steal, so that we can create, starting from this sentence, a question, a quite good sounding question, and a correct answer for that question. This is the idea behind how we can create questions starting from sentences. And keep in mind that we can do this for all sentences of all texts that we might want to analyze. What do we need to do this? So first of all, we actually need nothing special if we want to just try out the demo that Roberto has just shown us. If you want to do that via API, you actually have to first of all create an account for the Google Cloud Platform, and from the console of the Google Cloud Platform you can create credentials using the button that you can see here. And actually there are several ways for using these credentials, but a simple API key for a simple exercise like this can probably be enough for the moment being. Okay, so after doing this, we can try to use these credentials inside some Python code that will do more or less what we have just described. So let me get a very simple Jupyter notebook. This is a Jupyter notebook in case you haven't had a chance to use one. It's a simple interactive environment that allows you to execute some Python code piece by piece and even re-executing it without executing following things because you first want to check what the result is, or you want to make the code do exactly what you want so that you can test it before putting it into the workflow of your program. And here we are just doing, first of all, some very simple things like importing some libraries that we need. We are also importing a custom module that contains the API key that we generated for this example. And we are also preparing the document that we are going to send for analysis to the Google Natural Language API. Then we are calling, to begin with, we are calling the syntax API. Here we call the endpoint, and we get quite rich output. This is simply corresponding to what the visual demo also showed. And it contains a lot of information about the dependency links and the role of all tokens and so on. But not everything will be needed for what we are going to do. Here we are analyzing some custom data structures that are needed for our analysis, and like creating the nodes, creating a data structure for the nodes of the sentence and all their information, and most importantly, creating the links between these nodes and all other nodes in the sentence. We want to particularly keep track of which is the father node for each node, so which token every token depends on. And we also want to do something similar for the children, so the list of tokens that depend on the current token. And these are divided into left children and right children according to whether those tokens appeared before or after the current one in the original sentence. This can be useful because we also want to be able to reconstruct the sentence or parts of it, keeping the original order of the sentence itself. As you can see here, we are just listing token by token and its father and children dependencies. So the first token is Homer, and we see that it depends on Simpson because, as we have seen in the demo, Simpson is the main part of the Homer-Simpson expression, and Homer depends on Simpson. Simpson, in turn, depends on the verb stole. Usually in this kind of sentences, the verb is the root of the whole sentence. So the main subject depends on the main verb of the sentence. And we see that it has just one children, a left children, which is Homer, just because Homer appears to the left of Simpson in the original sentence, which was Homer Simpson stole, blah, 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 as you can remember. Just one more example, but then I guess you got the point. Stole is the main node, so the root of the node of the tree, and the convention in this case is to say that it depends on itself, so it depends on stole itself. It's of type root because it's the root of the tree, and it has one left children, which is Simpson, as we said, the subject, and it has two right children, which are conditioner and the final punctuation mark, which is the period. Okay, so let's go on. Here we are just defining a method for traversing the tree which means going from the leftmost node to the rightmost node in order, but keeping track of what depends on what. And we are just going to use it as a handler function for this next piece of code, where we are retrieving all nodes that are part of the subject group, and we are separating it from the rest of the sentence. And we are going to do something similar also with the object of the sentence. So we are separating the object group from the rest of the sentence, and we are going to use this information to create two separate kinds of question-answer pairs, which are these one. So you get the subject group is made of Homer and Simpson, and the rest of the sentence is stole Ned's air conditioner. By just adding the correct W question word, which is who in this case, and by also adding a question mark, we are getting who stole Ned's air conditioner, which is a reasonable question for this specific sentence. And it's also quite easy to build in this particular case. And clearly the answer is the part that was left behind, so Homer Simpson. We have something a bit more difficult if we want to build a object-based question, because we have an object group made of Ned's air conditioner, and we have a remaining part of the sentence, which is Homer Simpson stole and the punctuation mark. In this case, we do not we are not okay with just adding who at the beginning, but we have to produce that transformation that we mentioned previously, that exploits the presence of the lemma of stole inside the analysis. But after doing that, we are able to create what did Homer Simpson steal, and the final correct answer is Ned's air conditioner. Let me make one more thing precise. We are able to make the question and the answer sound more or less correct and complete because we were able to understand which were the links in the tree that we could not break, because we wanted to keep dependencies and relations between among the parts of the sentence. Finally, we are just calling the entity retrieval API, which are providing us information about Homer and Ned, which are of type person, and most importantly, we are getting a reference to the links of the Wikipedia pages talking about these two characters of the Simpsons series. This is actually quite important in our case, because we can try to use this information to do something more. We have a question, we have a correct answer, we still do not have some possible wrong answers, which are necessarily part of a multiple choice question. For example, you have to provide a good answer, but also some distractors, so some more answer which are not correct, but which are not obviously wrong. How can we do that? We can, for example, exploit open data structures, like, for example, Wikidata, which is a graph, a knowledge graph, an open knowledge graph that can be interrogated as using some API that actually contains references to entities that exist also in Wikipedia. And you can translate between from a Wikipedia link to a Wikidata ID, as we have done here. We have Homer Simpson, which is known as Q7810 inside Wikidata. What can we do with this? So we have our sentence, we find out Homer Simpson thanks to the Google Natural Language API, and we find out that this guy is Q7810 in Wikidata. Then we can try to ask Wikidata about which series he appears in. We already know the Simpsons, but we can do this automatically for other characters of other series if we want. And we get the information that this guy appears in the series Q886, which is the Simpsons. And then we can ask Wikidata which other characters appear in that same series. And we get this information and several others. So we get Mo, we get Krusty the Clown, we get Groundskeeper Willie, and so on. This can be considered a reasonable way to propose wrong answers, which are wrong, but not obviously wrong. They can be something that can fool someone when trying to answer a question generated as we have done previously. So this is the idea behind trying to use open data structures to generate distractors for questions. And so what have we, and why should we use the Google Natural Language API? There are several reasons. They are a cloud service, so you don't have to take care of the infrastructure, and you have a powerful infrastructure behind the service that can serve you well on the, let's say, availability point of view. It uses cutting-edge algorithm for language analysis and for entity detection. In our experience, we have seen these API to work quite well. And the function that retrieves the Wikipedia link is quite interesting and works quite well. It also can disambiguate in some quite difficult cases. And we said that it's a managed service. And yeah. So it's also maybe a matter of costs. So these APIs are not super costly.
How much did we pay for this?
I think much less than 1 cent of dollar. These are built based on units of thousands of characters, and you are built on thousands of the number of units that you are using. So let's say that about every million character you pay $0.5. I think something like that. And
okay, thanks, Andrea. I think that for those who are used to standard tools for natural language processing, like, for example, maybe you are familiar with NLTK or Stanford libraries, this is a quite good alternative. The main advantage is that we can use it as a managed service, and so you don't have to install anything. You just create your key, your Google platform key, and you can, with your credential, you can use this service and get the output. And the output is quite good in terms of quality. And we also made some comparison with the other libraries that we were familiar with, and I would say that the quality of this API are quite high and are able to identify entities and dependencies quite hard to be recognized. That leads us to the end of our webinar. I don't know if there are any questions that you want to ask us. Okay, there is one question about performance, and the guy would like to understand the time that a standard request to this API required. You know, Andrea, do you have an answer?
I think we are in the some tenths of millisecond, maybe a few hundred of milliseconds. It depends clearly on the length of the text that needs to be analyzed. It can depend on that quite strongly, actually. And there is a limit of around, I think, 1 million characters, maybe. Not sure about that, but there is a limit on the size of the text that you can submit for analysis.
Okay, and quite a technical question is whether Google API resolve coreferences.
Okay, so in case somebody wants to know what's a a coreference. What does resolving coreference mean? It's the natural language processing task of understanding when you have, for example, a pronoun, which entity of the text it refers to. So Homer Simpson stole Ned's air conditioner. He is a bad guy. We would like to know that he presumably refers to Homer Simpson. This is not an easy task, and I think there is not a straightforward feature for doing this in the Google Natural Language API. But I think they are able to understand that, for example, Homer Simpson, all occurrences of the name with just part of the name, for example, inside the same text, refer to the same person. So not for the pronouns, but you can do that when you have a repetition of the name in its abbreviated form, for example.
Okay, thanks, Andrea. By the way, we wrote a couple of blog posts recently, and you can have a look at some other details about both Google APIs, but also a comparison with the Stanford library. And there is another interesting question, who's asking how we could use this to extract the essence of an article, a blog post, or a web page. And I think that that's a quite hard challenge for a natural language processing task. And I say that you first of all need to understand which entities are the most important for your document. And this can be the API that gives you that value can be helpful for you to understand which are the most important entities. I also imagine that you can try to assign a score to each sentence you have to understand which are useless for your document. And I don't know, Andrea, if you have any other ideas to help in this task.
I guess this is a good approach, starting with this API. These are API for very atomic analysis of the text. The summarization of text that also produces a natural language summary of the text itself is a different task for which maybe these API were not designed, or at least not straightforwardly, let's say. But what Roberto suggested is a good way to begin. You would have to build something over this API to reach extraction of the summary. It would not be in the JSON that the API give you back.
Okay, thanks. So there are very different tasks that you can exploit with this API or with any other tool about natural language processing. We just mentioned generation of questions, summarization of text. You can perform sentiment analysis, which is, I guess, one of the most popular at the moment, especially commercially speaking. We can also try to extract entities in order to create linked entities and to have to add knowledge to our repositories. There are several tasks that you can run. So I hope our webinar was interesting for us. If you have any other questions, you can refer to our URL, which is cloudacademy.com/community. And thanks for attending. And bye-bye, Roberto
and Andrea.
Bye-bye.
Bye.